And we mentioned about this NSA and SA, and now it's time to introduce what is NSA and what is SA. Okay. NSA is realized in release 15, okay, early drop. Okay. NSA means non-standalone. Okay, NSA non-standalone. Non-standalone means that the 5G is not a standalone network. It will be together with LTE, with 4G. Okay, it's not independent network. Like this picture, the 5G and the 4G base station is at the same place. You can see 5G usually will cover a smaller range, smaller coverage, comparing with the LTE. LTE is the blue color, and 5G is the green color. The dashed line is the way for control plane, okay, for signaling, for control, okay, and the solid line is for user plane. So for signaling, the 5G base station will use the 4G LTE for the signaling communication. That is to say, the 5G will be communicated with the core network, okay, through the LTE base station. And the core network keeps the old core network, that is the EPC, 4G network. There is no NGC here, no new generation core, no 5G core. Okay, this core is a 4G core. Okay. Only for the radio, there is a 5G base station. So signaling for control plane goes through the LTE. And for the user plane, user's traffic will go through the 5G base station. Okay. And one mobile may have multiple link, okay, to 4G and 5G base stations, and this is called MSA, okay, multi-stream aggregation. So this is the very typical configuration, NSA, and now all the commercial network is using this solution, non-standalone. And SA is standalone. Okay, standalone means that we have an individual 5G network. 5G network and 4G network is separated. Okay, we have 5G core network. Okay, we have 5G radio, and you can see that 4G will go through 4G base station and 4G core network. They have signaling and have a user plane, okay, control plane, user plane. And also for the 5G, they also go through the 5G base station and to the 5G core network, also for control plane and user plane. So the name for the control plane user name, user plane is NGC and NGU, okay. That is, while for LTE, this interface is called S1, okay. Similarly, for 5G, just a new name. This is a real and a complete 5G. And nowadays, not commercially launched yet for the networks, but a lot of operators are making trial tests on the SA. And in the near future, okay, this one will replace this NSA. Okay, NSA is only a middle state now, okay, of the deployment of the network. And what are the advantages or what are the characteristics of NSA and SA? Now, here are some questions. So let's try to get the answer of the question. First one, suppose new services such as URLLC. URLLC. The URLLC is a service provided only by SA. This one. First question is, This is the characteristics of SA. NSA can only provide eMBB. Okay, this one only for eMBB. For URLLC and mMTC cannot be supported. Okay, we can say that it's also a partial function of 5G. Okay, decouple from existing 4G network. Decoupled from 5G network, an independent network. Of course, this is a SA, right? Because NSA is together with 4G, right? It needs the signaling path from the 4G network. And third point, the protocol is frozen by the end of 2017. So 5G can be deployed earlier. Sure, this is the description for NSA, right? The NSA is protocol frozen by the end of 2017. Focus on the NSA, right? Okay. The agreement is frozen in 2018. 2018. Okay. This is a SA. Okay. SA. We say this NSA is the early drop. Okay. Of release 15, and this is the main drop of release 15. Okay, continuous coverage is required of 5G base station. For continuous coverage, it is the SA needed because SA is a standalone. Okay, network is an entire network, so it needs a continuous coverage. But for the NSA, okay, it's only provided the 5G in hotspot. It does not need the continuous coverage. Okay? The continuous coverage can be provided by 4G network. While for SA, your 5G network is one individual network. Of course, it needs to provide continuous coverage. Okay. Less investment at the early stage of 5G deployment, right? Of course, this is the NSA, right? At early stage, you do not need to construct the 5G core. Okay, you only construct the 5G radio. Okay, new radio. Required to deploy NGC and deploy period is long, right? This is the SA. Okay, for SA we need a new core network, so it has much time and much investment. Okay, now we just know that what is NSA and what is SA, and that's a network architecture. And then we know that NSA was for the early drop. Okay, early drop defines NSA, and main drop defines the SA. Okay, focus on SA. And then for URLLC, for the release 15, only define the basic part. And by the end of 2018, okay, the URLLC defined is around, the completion rate is around 45%. And it will be completed complete by the end of 2019, okay, for release 16. That is to say that these URLLC are distributed in two releases, release 15 and release 16. Okay, release 15 define the basic part, and release 16 will define the enhanced part. Okay, only after this release 16 is frozen, can the URLLC can be commercially realized. Okay, so nowadays this URLLC cannot be commercially launched yet because the protocol is not frozen yet. Okay, this URLLC is to provide us low latency. Okay, low latency because some service need this low latency. For example, the to control the car, okay, automated driving or remote driving. Okay, we need very low latency because the car is driving with a very fast speed. Okay, so we need to make the end-to-end latency as small as possible. And you can see that this is the car, okay, using the radio communication to our base station. And then traveling through the access network, aggregation network, and core network, and then to our core, okay, next generation core. And this delay are composed of this air interface and the barrier network and the core network, okay. And for the air interface, of course, we can reduce this latency, okay, as much as possible. But only this interface reduce this latency. It cannot guarantee the end-to-end latency because we still need to go through the network in the middle, right? So the way to reduce this latency is that we may move this core, okay, the core network, near the user side. Okay, this will be realized by MEC. Okay, the mobile edge computing. Okay, so that is the solution. Okay, to reduce this end-to-end latency. And these scenarios, some examples like the smart manufacturing. Okay, Internet of Vehicle, and some cloud service for AI robot, okay, to control the robot. Okay. We need a low latency. So this is about the protocol progress definition of the URLLC. Another about the mMTC, massive machine type communication. Actually, this progress is hung up, okay, in release 15 and release 16. Okay. That to say the release 16, 5G will not be involved in LPWA, the low power wide area. And this will continue again after release like 17 and later. Okay. And nowadays in release 15 and 16, we will still using the NB-IoT or eMTC. Okay. And what can be the way to realize them is to embed this IoT, NB-IoT or eMTC inside the 5G band. And that is with the 5G band, we can deploy some NB-IoT or eMTC in it. Okay. So we can say that the mMTC, there will be no commercial usage. Okay. Until year of 2022. Before this year, it's impossible to have mMTC commercial deployment.